you can't expect to maintain biodiversity if people haven't got enough water to drink. But on the other hand, from the point of view of biodiversity, how do you expect that we're going to be able to maintain biodiversity in future if there is no water available? A lot of these systems are simply going to die.
Welcome to the Case for Conservation podcast. I'm your host, Andre Marder. First of all, Happy New Year to everyone for 2022. I hope that it's a very good one for you. The podcast is kicking off the year with a discussion that's a bit more ecologically specific than usual. It's about the state of freshwater biodiversity and how it coexists with humankind's need for water. I'm joined by Jenny Day, Emeritus Professor of Freshwater Ecology at the University of Cape Town. Jenny also happens to be my aunt and has been a big inspiration to me virtually since I was a toddler. She's worked in freshwater ecology for the past several decades, mostly in South Africa's superbly biodiverse Southwestern Cape, an area with considerable water management challenges. She's also done several sabbaticals in the US and Australia, so she has quite a global perspective on things as well. I started off by asking Jenny why it was freshwater ecology in particular that captured her interest.
I started off, the zoology department at UCT was very much a marine department. So I started off mostly being interested in marine biology. And when I was doing my PhD, my children were small. So I needed something that I could pick up and put down easily. So I decided to use the opportunity to do some systematics of a group of small marine crustaceans. So that was what my PhD was on, but systematics is not something that really is as exciting as it could be. So I was looking around for something interesting to do. And ironically, a colleague of mine, Jenny Jarvis, worked on small mammals in the Namib Desert, a couple of 1,000 kilometers away from here in Cape Town. And on one occasion, she was going up to her site in the Namib Desert, and she passed, on her way up, she passed a little rain pool. It had rained for one of the very few occasions in the Namib, and there was this pool with a whole lot of little crustaceans wiggling around in it. She went up and did her sampling and came back, and the pool was completely dry. And she'd heard that some of these small crustaceans could survive under dry circumstances. Obviously, they had to, otherwise they wouldn't exist there. So she collected some of the mud, and she knew that I was interested in small beasties. So she gave me a present of a plastic bag full of dry mud. And that's where it all started, because I put the mud into a plastic container, added water, and after a couple of days, the entire ecosystem was there. And to me, that was just the most remarkable thing. But I also discovered that obviously I couldn't always work on things that came from 2,000 kilometers away. Mm-hmm. So I started to work locally, looking at various aspects of rivers and so on. And it became very clear very quickly that if you are dealing with any kind of fresh waters or inland waters, there are such huge pressures. And at that time, there were so few people who were actually looking at them and had any expertise in knowing how to manage them, that you automatically became involved in management. And so virtually all of us that started as really just me and a colleague, and it's now several tens of people in this area. Mm-hmm. But we all are involved in both the science that really excites us, but doing the management, which we hope will allow these systems to persist so that we can carry on doing that science, mm-hmm. and so can the next generation.
I'm always interested in the difference between, when you talk about science versus management versus policy, those are kind of the three pillars that I often like to see conservation. Can you just give an example quickly of what you mean by science becoming management?
To continue with the small invertebrates that occur in our rivers and wetlands, mm-hmm. one can do the kinds of research that nobody's going to pay you to do. That is just scientifically interesting.
Mm-hmm.
And that, to me, would be the science. This often called the blue sky science. But the kinds of information that managers need is usually not particularly deeply analytical, particularly mathematical, but it's trying to identify issues that will be able to improve the ways in which they as managers look after the systems. So it goes from pretty much the sort of thing that I like to do because it's fun, even though it's science, and the sort of things such as being able to manage a particular wetland in such a way that it will be able to continue to sustain fishes and invertebrates,
Mm-hmm.
And to have adequate water quality. And in fact, water quality is one of those things that I've become most involved in recently.
Mm-hmm.
As for policy, eventually some of this lends itself to policy. And probably the most important aspect in South Africa is that after 1994, the politicians were very keen to change as much legislation as they could for fairly obvious reasons. But one of the things was to change the water law, legislation that dealt with the management of inland waters. And we were very fortunate to have a new Minister of Water Affairs, a man called Professor Kada Asmal,
Mm-hmm.
who was, as the Minister for Water Affairs, was in charge of developing the new water law, which became the new National Water Act. And we were very fortunate, we being the community of freshwater ecologists, were involved in the development of the legislation, which is about as close to policy as you can get.
Mm.
And so there were a number of meetings held with different groups of freshwater ecologists around the country, and eventually those were all put together, and it landed up that South Africa had the very first legislation that required that water should be provided for the sustainability of aquatic ecosystems. So the first amount of water has to be provided to individual people,
Mm-hmm.
what they call the basic water requirement, which at the moment I think is 25 litres per person per day. And that is the very first call on whatever water is available. The next call for water is to be able to sustain aquatic ecosystems, which is now often called environmental water allocations or in-stream flow requirements. There are lots of different terms. And South Africa has actually become a leader in that particular field. And then lastly, once those two, the basic water requirements and requirements for ecosystems, have been fixed, the rest is available for use by human beings. Of course, that is very much theoretical. And if there isn't enough water, then it kind of breaks down. But at least in theory, the aquatic ecosystems are protected legally.
So does that mean that they're kind of ahead of agriculture, for example?
Yeah, absolutely.
Okay.
Yes.
Okay,
yeah.
Interesting.
In theory, what happens is that for any significant water resource, a river, which the Department of Water Affairs is planning to dam,
Mm-hmm.
there will be a series of workshops at which hydrologists and biologists and water managers and local farmers and so on will all be involved
Mm-hmm.
in assessing how much water they need. A number of scenarios will be provided as to if you take 10% of mean annual flow, this is likely to be the consequence for the environment. If you take 20%, this is likely to be the consequence.
Mm-hmm.
And so in a system in which water quantity is not critical, it works very well. As soon as water quantities become critical, and of course more and more of them are becoming critical now as climate change is kicking in and there's less
Mm-hmm.
water available and there are more people, so it doesn't work nearly as well as
Mm-hmm.
it should do. But at least the legislation is there. That's where the science comes in the sense that there's a certain amount of fairly fundamental information required about the habitat requirements of fish and riparian vegetation and the appropriate water quality to maintain the river in a certain state, as well as how that is going to be handled.
Mm-hmm. It's actually a good segue to the next question, which was about the state of freshwater biodiversity. I remember, on various different state of environment reports and that kind of thing, freshwater biodiversity tends to be the most threatened and the most under siege, when compared with marine or terrestrial
Absolutely.
biodiversity, almost always, right? Like almost at every scale and every.
Yes, I think so. I think that there are more species of freshwater organisms that have become extinct as a result of human activities than in any other kind of environment. And this includes particularly fishes. I don't know the numbers, but it's something like at least 10% of the species of freshwater fish have either become extinct or are so close to becoming extinct that it really can be considered to be a major biodiversity crisis.
So I kind of asked you partly this question, but let me just follow up by asking about the state of freshwater biodiversity in South Africa in comparison with other parts of the world that you're familiar with.
Well, I think being in the Mediterranean part of South Africa means that for many complicated reasons, we have extremely high levels of endemism. So that for many of the invertebrate groups, there may be of 100 species that occur in southern Africa, 10 or 12 will be endemic to the very southwestern tip. And that means that the diversity is extremely high here and also extremely easily threatened because the area is so small, because we're going into climate change. So there's more and more variability in rainfall and stream flow and all of those kinds of things. Also, there is not a lot of money available for biodiversity research or protection. Whereas in somewhere like Australia, well-developed, wealthy country, there is the possibility of doing quite a lot to protect what biodiversity there is. I think in the States, it's kind of different in the sense that being in the Northern Hemisphere, there is less aquatic biodiversity in general, mostly because there was glaciation in the Northern Hemisphere through all of the Pleistocene. And that meant that the actual total number of species is much less, particularly of invertebrates per unit area. And on the other hand, the political situation in the States has meant that I'm sure you know that for the last couple of years, the EPA, the Environmental Protection Agency, has been completely decimated by politics. And they're getting things back together again. But there are all sorts of stories that really show that, at least in parts of the States, the issues have been inadequate protection of biodiversity. So here we have some very good organizations, particularly the South African National Biodiversity Institute, which is a government institute that deals with the protection of natural environments and biological diversity in general. But they're very poorly funded. So, there are always some good things and some bad things. And so we have this remarkable biodiversity. We have a lot of interest in it. We have a number of people who are working on different groups. The one group that is being very well looked after at the moment is the small fishes. We only have relatively small, and again, I'm talking about the Southwestern Cape, that area of what is sometimes known as the Cape floristic realm. And there are very few fishes larger than, maybe 20 centimeters. Most of them are really little. But the more people look at their genetics, the more it's clear that a lot of those populations are actually evolutionarily significant units in individual streams. Now, it's geologically a very old area. The streams have been isolated from each other for a long time. And there's been a great deal of diversification and speciation.
Speciation.
So very often there's very little evidence morphologically. They don't look very different from each other, but if you look at them genetically, they're very different, which means that virtually each of the streams needs to be looked after individually. But that's not easy to do. And then, of course, the biggest threat to the fishes is other alien introduced fishes like bass, particularly the trout and carp as well. But it's really the bass that just chew these little ones. So basically, very interesting systems, very interesting species, a unique assemblage of species of freshwater fishes and invertebrates, and lots of threats.
That's interesting. So I guess it's a general question because it might be different for different taxa, but generally speaking, are invasive species like bass the biggest threat to freshwater biodiversity in the Southwestern Cape? Or is sort of habitat loss and pollution or other drivers?
Andre, all of the above. There are the usual suspects. There's habitat loss, removal of habitat, particularly for wetlands, that cover it over and build on it, and then it won't be a swamp anymore. There's water quality, which is in some places particularly an important problem here in the Southwestern Cape, because apart from anything else, the water chemistry is very specific to this area. The water is very dark, full of organic acids, and the fauna is adapted to those conditions. So they can live at pHs of 4 or 5 as being the natural circumstances that they live in. If you then add any pollutants or you build a house or something, the pH goes shooting way up and it's no longer suitable for those organisms. So water quality issues of various kinds are a problem. Then there's the actual quantity of water. As I said, the Southwestern Cape is one of those areas where not only is the general climate models suggest a considerable increase in temperature, but also a considerable decrease in rainfall, which means that there's less and less water available. But at the same time, people need more and more water as temperatures increase. So that's the next thing. And then the aliens just sort of put the lid on the whole thing. So all of the usual suspects are here. And which is the worst or the most significant? I think it depends quite a lot on individual species and individual circumstances.
Just shift to water management, apart from conservation, and ask if you could, again, kind of sketch the situation in your part of the world, in the Southwestern Cape, especially with regard to the demand and supply for water. So this is in parallel with the usefulness of water for biodiversity. There's also, of course, the need for water by the human population of Cape Town and surrounding areas, which is increasing at the same time as rainfall is decreasing.
Yeah. A number of us have been involved in, about a year ago, there was a conference that was called Towards a Blue-Green City, Cities Influenced by Increasing Water Shortages. And we've just put together the proceedings of that particular conference. That deals with all of these kinds of issues in relation to the fact that 3 or 4 years ago, Cape Town came very, very close to running out of water completely. Everybody talked about day zero as the day when the taps would be shut off. And we really were within less than a month of that happening.
Wow.
And fortunately, it rained. But the reason that it happened was it was essentially climate change, in that the city had been very good and is still very good about trying to make sure that there's enough water for domestic purposes and industrial purposes and some agriculture. And in fact, they had a 5-year plan, which was to end in 2017, which dealt with these issues very well. And the city was awarded a prize for the most effective water demand management systems. And almost the moment that it happened, we had 2 years with virtually no rainfall. Now, there had been plans in place for 1 year with very reduced rainfall, but 2 in a row was just impossible. I think it was summer of 16, 17 and 17, 18.
Okay.
And it was in winter of 2019 that we actually started to get good rains again.
Okay.
So the issue is, and it's at the moment, in most of South Africa, we have quite good rains. El Niño is operational at the moment, so we have quite good rains. Another couple of years, and La Niña is operational at the moment. El Nino will come back, and then we'll have the same sort of problem again. So there really have been very big challenges with being able to try and maintain sufficient water for the purposes of a city. And it's had some interesting consequences for biodiversity in the sense that the city engineers, the water engineers, have been very much aware of the fact that there was less and less and less water available. So the knee-jerk reaction, which is hardly surprising, is we've got to find water from anywhere we can. So any of the policies which were in place to maintain certain areas with the amount of water that would normally be provided suddenly went out of the window. The argument being, and again, I entirely understand it, you can't expect to maintain biodiversity if people haven't got enough water to drink. But on the other hand, from the point of view of biodiversity, how do you expect that we're going to be able to maintain biodiversity in future if there is no water available? A lot of these systems are simply going to die. So it's a really, really difficult thing to balance. What happened was that all the caveats that had normally been employed to make sure that environmental impact assessments had to be done before the development of any new water development were suddenly off the table. And there's also a very large, but we don't know how large, very deep aquifer called the Table Mountain Aquifer, which underlies most of the Southwestern Cape. You can take Cape Town as being the bottom left corner of a right angle triangle. Then the distance from Cape Town east is about 400 kilometers. The distance from Cape Town north is about 200 or 300 kilometers. And virtually underneath all of those Table Mountain rocks is this very big, very deep aquifer. The weird thing is that it's also very fresh. Normally, extremely deep aquifers are saline. So it looks like an absolutely wonderful source, and it is a wonderful source of water. But up to then, the city had been very cautious about not using any of that aquifer until it was clear what the effects would be. Because in particular, it was very difficult to know, and they still don't really know, how rapidly it's recharged. In other words, how much water can you take from a particular part of the aquifer that is going to be recharged by rainfall over the next couple of years, and how much, if you remove it, is actually, to what extent are you just mining and it's not going to be replenished? So there were interesting projects being done to try and find out answers to these questions. But in the depth of the drought, the geohydrologists said, there's that water under there, we're going to drill for it. And all the EIAs and everything else just completely went out of the window. Then, of course, the difficulty is that once that's happened, and we're suddenly no longer in the desperate situation of day zero approaching, it's very difficult to explain to those people who are now planning to make great big holes in the ground that they really should stop and consider what the effects are going to be and do proper EIAs. So it was a very good example of how management can be derailed by a sudden crisis. One of the other things that they're doing, which is very interesting, is that is a very deep aquifer, 2,000 meters, 3,000 meters deep. But there are other much shallower perched aquifers which are within 50, 100 meters of the surface. And those are being used more and more for agricultural purposes and also as part of the city water supply. And so the latest idea is to recharge them using purified sewage effluent. And that project is being developed right at the moment. And so one of the things that everybody is concerned about is what the water quality will be like of the water that is going into that aquifer.
Mm-hmm.
But the city is being very careful about doing some excellent monitoring, not just of the usual things like salinity,
Mm-hmm.
but looking at what are sometimes called contaminants of emerging concern, like pharmaceuticals and things like that.
Mm-hmm.
So there are always challenges in trying to provide water for cities, but when you have a system with a rapid deterioration in the situation, it can become very challenging.
Mm-hmm. I'm interested in the trade-offs between these two kind of fragile situations that you've outlined, the biodiversity situation on the one hand and the human need for water on the other hand in a drought-prone city. Are there opportunities that work toward both freshwater biodiversity conservation and the management of water supply and water quality for human consumption? Those kind of win-win situations. And then on the other hand, are there also times where they're just simply incompatible? Those two goals are simply incompatible with each other.
Well, I think that when the quantity of water really becomes limited, then it's extremely difficult to have any sensible trade-offs. But on the other hand, it is possible to do quite a lot to improve the situation. And the Nature Conservancy has been involved both in Cape Town and in various places around the world in having a look at ways of what they call nature-based solutions.
Mm-hmm.
The Nature TNC, the Nature Conservancy, has been investing in ecological infrastructure, as they say, as being the most cost-effective long-term solution for securing water. And mostly what they're doing in this part of the world is controlling invasive alien plants, which use up an enormous amount of water, and rehabilitating wetlands. And they suggest that the business case for Cape Town shows that investments in nature-based solutions, including controlling invasive alien plants and rehabilitating wetlands, can generate as much as 55 billion litres of water per year. And that's equivalent to about 2 months of Cape Town's current water supplies. And the quantity, the proportion will increase within 30 years as more of the invading alien trees are removed and wetlands are rehabilitated. And such water gains can be achieved at 1/10 the unit cost of alternative water supply options and can create up to 350 jobs as well. And in a place like Cape Town, jobs are really, really important. So essentially, that's looking at the alternatives, not just in Cape Town, but in a lot of different places. And in Cape Town, one of the important things, in fact, in South Africa generally, one of the important things is the huge number of alien invasive trees, most of which come from Australia. I mean, we have provided the Australians with some nasty invasives, and they have retaliated. And so one of the main things is actually to get rid of those trees. It's easier said than done. A lot of them are in very difficult to access places. But the main thing is that once you get rid of them, when they occur, they can germinate in such huge numbers that the area where they are can be virtually impenetrable. So it's really difficult to get at them. And once you remove them, there's a huge problem of soil erosion and the loss of native vegetation. So it's not a simple process, but certainly it is very helpful. And if it's done properly, and as long as the areas are kept clean of those invasives, then the amount of water available is considerably more. Right. Of course, the other thing to do is, it sounds very simple and easy, is water demand management. Just making sure that the citizens are given the best incentives to use as little water as possible, that tariffs are designed in such a way that it's a sliding scale, and if you use a lot of water, you pay a lot more than if you're using a small amount. So all of those things can help.
So those are examples of where you're going to be benefiting both biodiversity and society, basically. And then, so you mentioned that on the other side of the coin, when water is scarce, then it's really difficult to do things that benefit both. But even under normal circumstances, when there's no drought, are there sort of circumstances where those goals are incompatible with each other?
I think probably not really, but I think also that politicians often don't realize that.
Mm-hmm.
It needs a lot of political will to consider this to be important and to recognize that there are ways of dealing with these issues. So under normal circumstances, in other words, when there isn't a drought, it should be possible to maintain the careful balancing between how much water goes to people and how much water remains in the environment, which is what the water law tries to do. The water law is very, very poorly implemented, by the way, but at least in theory, that's what happens. So I think that a lot of our problems deal with the fact or are due to the fact that climate change is really having an effect on water. And if you look at places like Australia, the decade-long droughts that are occurring in different parts of that country, that continent, just show how devastating the consequences are of having less water and higher temperatures.
Yeah.
I mean, there are other things that can be done. For instance, there's the notion of virtual water, which is considering how much water is actually, in a theoretical sense, incorporated into all of the goods that we use. So it would take, I don't know the numbers, but it might take 50 liters of water to produce 100 grams of beef, but only 10 liters of water to produce a cupful of rice, and a large number of liters of water to produce a motor car. Now, one of the ways that can be useful is to rearrange particularly as far as agricultural products are concerned, to require that the water-hungry crops are grown in places that have got enough water, and that the more drought-adapted crops can survive under circumstances where there is very little water available. Because in South Africa, and I think it's probably true in many parts of the world, the amount of water that is used, of the total amount which is used for human purposes in a year, probably at the moment it's about 55 to 60% goes to agriculture. And that's partly because if one could start right from scratch and then allocate people and crops in certain places, that would be very helpful. But of course, you can't do that because people are already there and they're already farming and they're already concerned. And added to that, the heartland of the country is the area around Johannesburg and Pretoria, which developed because of gold mining. So there are these enormous cities that, if one had a choice as to where to put a city, that would be the very last place you'd choose. Because they're in highly elevated areas, there's not a lot of water around, there are very large populations, there are very dry winters, and so on. So one has to accept the fact that you're not going to be able to change that. But what you can do, and that I suspect that at some stage, the government might need to provide incentives to farmers to farm appropriate crops. So you don't try and plant cotton, which is incredibly water thirsty, in areas where you have to use a lot of whatever water supply reservoirs have got. It's cotton and sugarcane is another one. Those are both very thirsty crops that people like to plant because they have high returns. But sooner or later, there has to be a way of being able to say, if you live in a particular area, you probably shouldn't be growing cotton, for instance.
I know this is not really your area, but I wonder how much of a role technology has to play here. I'm thinking about genetic modification and precision farming, which is something I don't know very much about, but it's basically the idea of, being absolutely pinpoint accurate about how much is needed in terms of water and other inputs, right? But at the same time, it's kind of a bit of a race against the climate,
I
right?
think so, yeah. And I think it really is a matter of farmers considering what the alternatives are, because the price of water surely is going to continue to increase. So if they can be as clever as possible about what they grow, then everybody is going to win, or nobody is going to lose any more than they have to. There's a chap in the Karoo, in the really, really desert area, and he inherited this farm from his father. The father had developed the farm at a time when there was a lot more water around, not necessarily as a result of climate change, but climate also does tend to alter over time. And he decided that if he wanted to keep his farm, that he would have to choose appropriate crops. And he chose a really interesting selection. One is figs. Figs have traditionally been grown in really arid areas. Another is pomegranates, which are also grown in very arid areas. And oddly enough, the third is onions. And he has spent a lot of time getting in every variety of those crops that he could, and doing some experiments to find out which ones survive on the least amount of water, particularly since the water is somewhat saline in the Karoo. So they need to be really, really tough ones. And he's doing extremely well. And that is a real extreme. I mean, I'm incredibly impressed by him. He's somebody who said, okay, this is what the situation actually is. There's very little water available. Can I farm here, or am I going to have to give up? And the answer is yes, he can.
Just by being adaptive.
Possible. By being adaptive, yeah.
Okay, that's it for the first episode of 2022. Remember, as always, that you can find links to resources relevant to our discussion on the webpage for this episode at caseforconservation.com. That's with the number 4 between case and conservation. Next time, I'll be talking with Stanford University economist and food security expert Ros Naylor. We'll be discussing something that I've wanted to talk about for some time, the pros and cons of aquaculture, which is where an increasing proportion of water-based food comes from around the world. Ros was lead author on a review of global aquaculture in the journal Nature in the year 2000. 20 years later, she led a similar team of researchers in a comparative study. Our discussion will include how things have changed in those 2 decades. This is largely a good news story, and a very significant one at that. Please join us.